1b from the free response section. This is a bacteria problem given with the table. It says the total mass in milligrams of bacteria in the petri dish is given by the integral expression 2 pi times the integral of f of r dr from 0 to 4. And it says approximate value of this integral using a Wright-Riemann sum with 4 subintervals indicated by this table. So that's these 5 coordinates will give us the 4 subintervals. Now first of all, it's important to understand what the 2 pi r times f of r dr actually means. So if we take a look at 2 pi r dr, really this is the area of a circle. If I integrate this, I'm going to get pi r squared. So this is essentially giving me the area of the circle, and this is giving us the 2 pi times r f of r dr is then just going to introduce the density, which means we're going to take the area pieces and multiply it by the density, which then gives us the total bacteria. So this is going to calculate the total bacteria. So to do this, what we want to do first of all is I'm going to convert this table, and so because I want to find out the area underneath this curve here using a Wright-Riemann sum, so I need some coordinates on that curve. So I'm just going to use this calculation to calculate 2 pi r f of r. So if I put in 0 into my equation here, I'm going to end up with the value of 0. If I plug in 1, I'm going to get 2 pi times 1 times f of 1. Well, f of 1 is 2, so we end up with 2 pi times 2, which is 4 pi. Okay, if I plug in r is 2, I get 4 pi times f of 2. Well, f of 2 is 6, so we end up with 6 times 4 pi, which is 24 pi. At 2.5, I've plugged 2.5 in, I get 5 pi times f of 2.5, which is 10. So I get 10 times 5 pi, which is 50 pi. And then for f of 4, I'm going to plug r as into r of 4, so I get 8 pi times f of 4, which is 18. And for that, I'm going to get 18 times 8 pi, which is 144 pi. Okay, so those are my 2 pi r f of r values. So if I just plug those in, I'm going to get this. So I'm just going to scale this. Let's say that's going to be our maximum 144 pi. So 50 pi maybe somewhere around here. Okay, 24 pi is about half of that. 4 pi is really low. Oops, I think I've made a mistake here. So 50 pi, 24 pi. This is, oh, I don't need a point there. So 2.5 is going to give me my 50 pi down here. That's going to be our 24 pi somewhere around here. And our 4 pi value is maybe down really small here. Okay, so I need to use a Wright-Riemann sum. So I'm going to use these Wright-Riemann rectangles here. So if I sketch them in, I just need to take the height times the interval width to give me the area under that curve. And that area we know represents the total bacteria. So our total bacteria here is going to be 4 pi times 1 times 1. We're going to have here, this is going to be 24 times an interval of 0.5, so it gives us 12 pi. This is a height of 50 pi. Okay, so that's going to be 50 pi about here. About 24 pi. And then our 4 pi is way down there. Okay, so this is going to be a height of 50 pi with an interval width of 1.5, so it's going to be 75 pi. So when I take the total area, then if I add this all up, I'm going to end up with 91 pi bacteria, or milligrams of bacteria. Okay, and then working that out as a decimal value, it's 91 pi. I get 285.88 milligrams of bacteria. Okay, so part C here says, is the approximation found in part B an overestimate or an underestimate of the total mass of bacteria? So if we think of this problem here, this is really a strictly increasing problem. So I start with 0, I go up to whatever that value is, and really this is a strictly increasing problem. If I take a look at the area underneath that curve, as long as it's strictly increasing, okay, and we have no reason to believe it's going to decrease, then we know that because it's strictly increasing, we know that this must be an underestimate. We could just tell by looking at the bars compared to that red line, know that this is an underestimate as well. So to give a more thorough explanation, we can just say that since the graph is strictly increasing, the right Riemann sums must be an underestimate. Okay, and so we know that we can use this reasoning. We can really justify it with the picture, but we can also use this reasoning that because of the strictly increasing nature of this graph, we know that those bars must be below the curve.